Imagine a billion-dollar AI data center. Thousands of cutting-edge GPUs are installed. The cooling system is ready. The software is waiting. And yet, the entire facility could still be unable to run because of a machine based on technology developed more than a century ago. AI companies are already racing to secure enormous amounts of electricity. Some are even looking beyond the traditional power grid. But producing electricity is only half the problem. You still have to get that electricity into the data center.
And between the power plant and the GPU sits one of the least glamorous but most important machines in the electrical system: a power transformer. Transformers allow electricity to travel efficiently across the grid at very high voltages, then change that voltage into forms that substations, buildings, and eventually servers can actually use. The basic technology goes back to the 1880s, and that creates a strange irony. The future of artificial intelligence is becoming increasingly dependent on technology whose roots belong to the 19th century. There is another coincidence that makes this story almost perfect. Modern artificial intelligence was transformed by an architecture introduced in 2017 called the transformer. But the physical computers running those transformer models still depend on electrical transformers developed more than a century earlier. One transformer helped create modern AI. The other may help determine how quickly we can build more of it. And suddenly, this old piece of electrical equipment is facing a completely new kind of demand. And the pressure is growing fast. The International Energy Agency estimates that data centers consumed around 485 terawatt-hours of electricity worldwide in 2025. By 2030, that could rise to roughly 950 terawatt-hours. Electricity use from data centers focused on AI is expected to grow even faster. So the AI boom is no longer creating demand only for GPUs. It also needs transmission equipment, substations, switchgear, cables, and transformers. A digital revolution is creating an enormous demand for very physical machines. So why not simply build more transformers? Because the largest ones are nothing like computer chips. A large power transformer can weigh hundreds of tons, cost millions of dollars, and many are custom built for the exact requirements of a particular part of the grid. They require enormous quantities of copper, specialized electrical steel, insulation, skilled workers, manufacturing capacity, and extensive testing. Then they have to be transported, installed, connected, and tested again. This is not a product you can manufacture like a smartphone. And transformer factories cannot instantly double their capacity. And this is where the mismatch becomes painful. The US Department of Energy has reported lead times of more than 36 months for some large power transformers. More than 3 years. In electrical infrastructure, that is a serious delay. In artificial intelligence, it is almost absurd. 3 years can mean several generations of AI hardware. Entire families of models can appear. Billions of dollars can move between companies. But the transformer ordered near the beginning of that race may still be somewhere in the manufacturing process. And that reveals the real problem. AI and the power grid operate on two completely different clocks. Software scales at digital speed. Electrical infrastructure scales at industrial speed. A model can be copied almost instantly. But you cannot download a transformer. You cannot generate a substation with software. And you cannot prompt an electrical grid into existence. It takes steel, copper, factories, engineers, permits, construction crews, and time. So even when an AI company secures enough electricity, the infrastructure required to deliver that power can still become the bottleneck.
And this changes what the AI race really is. The winners may not simply be the companies with the smartest models or the most advanced chips. They may also be the companies that can secure land, electricity, transformers, substations, cooling systems, and grid connections faster than everyone else. Artificial intelligence is becoming a physical infrastructure business. And if the traditional power system cannot expand at AI speed, big tech has another option. Move further upstream. Find an enormous source of reliable, round-the-clock electricity and bring it closer to the data center. That requirement is pushing some of the biggest technology companies toward an energy source Silicon Valley once had little reason to think about: nuclear power. Which raises the next question. Why are software companies suddenly making deals involving nuclear reactors? Because the AI race is no longer just a race for intelligence. It is becoming a race for power.